tried this practice problem. So you should have got these two values for the speed at which we get to point D of the square root of 7/2 GR. And for the coefficient of friction that causes it to stop from D to E, you should have got this 0.583. So let's go through this just to see how that came about in case you did get stuck. So if I think about going from point 1, where I have no kinetic energy, only potential energy, there's no friction, so I should end up with something that looks like 0 is equal to K2 minus UG1, meaning I end up with 0 is equal to 1/2 mv squared minus mgh. The masses cancel and v equals the square root of 2gh. The trick here is I can't just leave it as h because that's not a variable that they tell me. So what I have to do is I have to go, okay, if this is r and this is 3/4 r, we get a total of 1 3/4 r or 7/4 r. So v is equal to the square root of 2g times 7/4 r. Now yes, I can leave it like this. This is in variables that I can use. R was one of the values they said. It said, yep, it did give me r and gravitational constant. Now if I want, I can turn this into a 9.8 or a 10, or I can leave it as g. I did choose to simplify my 2 and a 4 down to 7/2 instead of 14/4 or just leaving it like this, but this is acceptable. All right, for part D, they want to figure out the mu value in order for it to stop. So you have one of two options here. You can either go back to the start and then end here, or you can go from point D to E. Either one is acceptable. I think I'll go from D to E. So I have the work done by friction, and I have the kinetic energy at the start, negative K1. So now I have mu times the normal force, and it's negative times the distance it goes, 3r equals negative 1/2 mv squared, the v I just found here. So I now have negative mu, and it's on a flat surface, so my normal force is mg, 3r equals negative 1/2 m times v squared, so now I have 7/2 gr. So now I can go ahead and cross some stuff out here, which is pretty cool. So the m's cancel, the g's cancel, and the r's cancel. The negatives cancel, and so all I have to do is bring that 3 over. So now I have mu is equal to, all right, so I have 1/2 times 7/2 times 1/3, or divide by 3. Either way, you want to put that all together. So I end up with a mu is equal to, oh, what am I doing there? That's a 2. So I have 4 and 3, so that's 12. So I have 7/12, which if I put on my calculator, I do get that 0.583 number. And of course, no units on that mu. There you go.